as well as the component loads, and this becomes very important. Over the past decades, many developments have taken place. Rapidly developments are taking place in our country too. And this terminology of the composite materials have become more and more familiar. We are becoming familiar with the terminology, especially when we are going through our undergraduate and postgraduate education. I think the composite materials just been introduced. In fact, we did not study much during the undergraduate education. The postgraduate education, I think, was Muralidhar will agree. The metal matrix composites were made particularly for the first time in India, first time in Asia. And I'd also like to tell you, we are greatly benefited by the research talents of Professor Muralidhar. We were together in Institute of Science. As a matter of fact, he has given a lot of informal guidance without really becoming my guide. Their efforts in the area of aluminum materials made us get into the ferrous materials, and also where I was working in Western Compton, he was there as a senior member, and there also derived a lot of benefits by interacting with him. So I am very happy again to be here. As a matter of fact, Professor Muralidhar, I think you would have used one of the earlier machines in CPRI, and CPRI was in ISC, that one of the on-speed machines. I think many of our senior colleagues had used. In fact, I have kept the on-speed machine very safely in our division, just as a token of remembrance. Why I'm mentioning this point is the structure property relationship should be correctly established, especially most of the composite materials. It is not very simple, and we have to go deeper and deeper into the subject before we get a proper understanding of the material. And the current trends and the future trends all depend on the developments in the composite material, how they are intended for use and how they are used. In fact, the striking examples of breakthroughs are based on the utilization of composite materials. Increasingly in the transportation sector, actually we get an opportunity to look into some of the vehicles inside. I think we may not be knowing that some of the vehicles we are using are having a composite materials. We may not actually open the vehicle and see. Long ago we used to have that advantage, nowadays we don't have. Because we are all too busy and we don't look into what's around us. Transportation, and then buildings, the civil infrastructures, holding, and many other areas. If I tell you in the global perspective, the composite materials, if you take the overall, I think if you just make the conversion into rupees, I think it exceeds 90,000 crores, the turnover of the composite materials. And the improvement, though the overall world economy is a bit sluggish, there is 8 to 10% improvement every year in the turnover on the composite materials. It's not very ordinary. And very surprisingly, the improvement is more than 25% in India. That means every year after year, we are investing more and more, we are utilizing more and more, we are experiencing more and more about the composite materials. But here, what is the role of scientists and engineers, we have to really keep in mind, as that Ramurthy rightly put, the transportation we are using nearly more than 4%, marine nearly 70%, construction and aerospace industry nearly 10%. The energy sector, wind energy sector, nearly 40% composite materials are used. Exactly what is inside, how these materials are made, and how they are actually assembled, how the performance is evaluated, that's very important. I'd also like to tell you, there has been a number of conventions in India. The recent one was in January in the Institute of Science, especially the composites for the next century. Various aspects have been looked into. I'm sure in this seminar too, some of the papers presented will cover the advances. The novel aspects are nano composites, multi-functional composites, computational modeling, non-destructive evaluation, dynamic behavior, structural health management, and how the composite applications spread over the various multiple applications. The fatigue, fracture and damage tolerance. And another point where we are very much interested is the high temperature applications, high temperature composites, especially in the power industry, and the manufacturing techniques of these high temperature composites. The composite, as well as polymer industry, high temperature means somewhere around 90 to 100 or around 50. That was thought earlier. Now we have the composites which can go up to nearly 250 to 300 degrees that can be constructively used. And the biocomposites in medical surgery, and also finally the composites for the power sector. Composites for the power sector, I'd like to give you a brief, maybe 1 minute later. But what is very strikingly important for us is to understand that the composites are expected to be the preferred material in the future. So wherever we are using conventional materials, there are aluminum, the high-strength aluminum, even the conductors, which are aluminum, I think will be replaced with composite conductors. If you get into superconducting power energy devices, they are all made of composite materials. How these are made, I think even examination of what is being used throughout the world, that itself is a very good learning exercise. If you look at the development as well as the potential for growth geographically, developing countries, especially BRIC, B-R-I-C, Brazil, Russia, India and China, I think the BRIC countries rule the whole world. And here it shows an amazing potential, the rapid growth and urbanization as well as the potential shows the evidence of emerging middle class. So with the result, the application of composites in the social sector as well as the engineering sector is increasing enormously. And if we just find out the per capita consumption of reinforced plastics in India, in fact right now it is much lower than North America and Europe, but in future it is expected to improve. As I told you, improvement is nearly 25% every year. And the reinforced plastics are more and more competitive and the prices are dropping down. But the resins and the fillers as well as the processes, this is very important. The processes are not yet optimized. The high economic growth rate in India offers many opportunities for reinforced plastic industry, especially in the infrastructure and the energy sector. Let me tell you a little bit about the energy sector. We were almost nothing when we became independent, just about 1,000 megawatts or so. Now we have 1,60,000 megawatt capacity power plants. And what is very surprising is, see, over nearly 5 decades we have added nearly about 1,60,000 megawatts. And almost 1 lakh megawatt is going to be added in the next 10 years. And as much we are going to add by 2020 will be added by 2030, next 10 years. That means the power plants are recording exponential growth. Why it is so? Because the GDP of the country depends upon the availability of power. Power and GDP are closely related. The growth rate in the GDP, which is about 8 to 10% as we want to achieve, the power plant, power generation capability as well as the transmission and distribution capability also should increase much more. But what is very striking is the composite industry also is growing at the same rate, actually much more, at the rate of 25%. So the growth of power, growth of GDP, growth of composite industry, I think they are all going hand in hand. So composite industries, I think, is the right time for us to actually look into the various advances made. Many IITs, IISc and all the NITs are leading R&D centers are there in the country. IIT Madras.